Good morning. It is Friday, I think. Yes, it's Friday. Um, and we're rocking and rolling. Okay. So where were we at? We committed uh, the initial set without edits. So let's take a look here again and say, hmm, GraphQL query output. Okay. So, hmm, so we need to find the edit. Discussion, comment, discussion, comment, um, edit, reply, user content edits, user content edit connection, user content edits. So here's our discussion comment, right? So I don't know what the quoting, is there commenting in this? Whatever. We define, we'll put it in the doc. Okay. I set up speakers. It is great. Okay. We define fragments which are like uh, what we want, are saying what we want from a given type. Okay, like a select. Yeah, I've never really used much GraphQL. We're about to use a lot of GraphQL. Are we? Yeah, I think it'll be nice. I think we'll grab that strawberry library, provide an interface. I think that'll make data flow execution pretty easy for people. Okie dokie. What did we want? Okay, yeah, let's update this. User content edits. First 100. I'm pretty sure we don't have more. I don't think I edited a. Ooh, I don't think I edited a comment more than 100 times. I may have. We'll find out. User content edits. So where's user content edits? Thank God that somebody gave GraphQL API. I don't think we would have been able to get the markdown otherwise. I totally forgot about that with the scraping approach that I had gone with at first. It returns the elements unless they come after a specific. Well, we would have been able to get it eventually, but it would have been. This is probably easier. User content edit connection. User content edit connection. Using GraphQL API for discussions. Can you hear me? Hello, hello, hello. All right. None of you can hear me. Perfect. Um, hopefully somebody can hear it eventually. Okay, so if you care about GraphQL deciphering, which if we finish Alice, you hopefully don't have to. All right, where is this? Give me this. Nodes. Always with the nodes. Page info. Total count. edge. Ooh, an edge is like an input object. Let's make a note of that. A GraphQL every, oh, well, that was the whole point of what we were doing anyways, actually. In edge suffix in GitHub docs looks like an input. Man, it'll be so sweet. We'll be able to. Okay, so user content edits. User content edit diff. Updated at, edited at. Okay, diff. The summary of changes. Diff. Edited at. All right, we'll grab the date history as well here from this whole thing. So we want last edited at or created at. Okay. 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 Run the query. Field diff doesn't exist on user edit connection. Oh, nodes. Trade traverses. Boo, boo, boo. User content edits first 100. Okay. Applies first 100. Okay, so we got the first 50. Hopefully I haven't edited anything more than 50 times. User content edits. I wonder if we lost anything. Let's grab the, from each thing that's like, so from each thing that has page info, total count, information to age, and page nation. Okay, yeah, so let's do page info on each of these things and total info. So anytime we do anything where we return nodes, total count. Okay. Anything where we have a nodes return, let's grab that. Okay, go fuck yourself. Page info has previous page. Okay. Yeah, I'm starting to get the hang of this GraphQL. This is pretty sweet. So, okay, we care about the end cursor. Start cursor. Okay. All right, so we only care about has next page. So fragment on page info. All right, so fragment page info on page info. All right, so now we can take this thing and we can say dot dot dot. Fragment page info was defined but not used. Missed the capitalization on the I. Can't be spread inside discussion comment connection. Okay. Discussion comment connection. Where's comments? Comments. Discussion comment connection. So this has page info, nodes, and page info. Let's try lowercasing it. Oh, wait, here. Fragment page info on page info can't spread inside discussion comment connection. User pin discussion. Why? Why can't you spread? Motherfucker spread. God damn it. Nodes comment. Fine. I don't want to do this. I'm not doing this. It will spread. Let's see. Comment. Fragment. GraphQL. Mutation. Add post. Mutation variables. GraphQL variables. Fragments existing dgraph. I don't know what dgraph is. What is dgraph? Okay, whatever. I don't care about that. Mutation, add post data, post. Query character. All characters type. Influence character in play. Oh, this is great. Oh my gosh. This is going to be fantastic. Um, Maybe that's not what GraphQL spreading is all about. Okay, fine. Total count, page info. Oh yeah, because it's not big enough to need that. There's only 3. Fragment page info was used but not defined. Oh. Huh? Oh, here. It's up here. User content edits. All right, well, this should tell us if we have more records or not. Total count. Let's see. Get grep. Has next page true? That's what we want to know. Did we get everything? All right, great. We got everything. Okay. From we got everything. Otherwise, write page nation code. There should be some in the in GitHub operations somewhere. The following command returns no results if, okay, and let's just do has next page. Wait a minute. Oh, wait a minute. Okay, I'm glad I tried that. Okay. We can go through and inspect all of these, say false, right? Or we can just go through and say grep true. Okay. The following command returns no results if we got everything. and don't need to page nate. Okay, nice highlighting. Okay, so, oh, that makes me very happy. Okay, so now we can do our dump discussion thread. We've got all our diffs. Okay. All right. Okay, so we need to, when we write these things out, upper margin. Okay, so let's take a look at this and say def right file, right? So now let's make this data flow because it'll be a little more interesting. All right. Oh, is diff broken right now? All right, I think I overrun main. Okay, we'll put this stuff in here. Import async IO. All right, yeah, okay, diff, no, it's messed up right now. Okay. Okay. Let's go. All right, where's that nice data flow that we were using? Oh, overlay. Overlay, overlay. Okay. Okay. So what do we want to do? Yeah, we want to output markdown to the directory. And apply every diff. And then we want to, okay, so we want to write the output to the file. And then we want to go through and apply every diff. Okay. check that, get variable commit. I'll be right back. Okie dokie. Here we are. So if we, so where's our diffs? All right, so here is some diffs. Let's see, diff, diff. Those are not diffs. That's not what I call a diff, but fine. End cursor has next page false. Okay. Total count 4. Total count 9. Okay, so we'll go through and check that total count equals len nodes. Okay, so run. Quick and dirty. All right, we're just gonna run the data flow. Okay. All right, so we want to apply all those diffs. So I think what we can do is we can git commit. I think the best way to do this is to let's look at our data. So the end of the list of nodes with the diffs. So basically, this is the oldest version. It looks like. So we'll grab edited at. We'll add. Okay, so created at will be or edited at. Let's see. So what about this one? So created at blank. Okay, so that is the first edited at time. Okay, so we can just, for anyone that has, okay, so the rule is if it has edits, is this the same thing? Is the latest edit the same? All right, no, the latest edit does not look the same. Oh, maybe it does. I can't tell. We're going to put it in another file. Looks the same. Okay, so the latest edit, so if there is a latest edit, then, okay, so if there's no edits, we just commit the file at whatever the created date is. Okay. So if no edits, commit the file at created at state is if there are edits, um, take, okay. So if there are edits, then we want to do a commit for each one. Okay. So how is that different? So basically take this contents committed at this time. Okay. Okay. I think what we could have her do is, um, hmm, what she could do. Okay, so, all right. Okay. What should we say? How would we say this? How would we tell this to Alice, right? Like, what do we want her to do? Well, so, uh, Alice, no, if there are edits, uh, ensure the repository always maintains. Okay, so if there are edits, ensure they are committed in the correct order, uh, sorted by date with latest being the most recent commit for that file. Okay, if there are edits, ensure they are committed in the correct order. Okay, so Alice, ensure the repository always maintains, uh, always is always never more than, okay, so ensure the repository is never more than one commit away from being sorted by date with the latest change as given by the date field being the most recent commit. Ensure the repository is never more than one commit away from being sorted by date with the there is never more one commit. Ensure the repository. Ensure that the repository never has more than, okay, okay, so, okay, so we feed all of the edits in. So this is the content of the file at this time. Okay. So imagining the rebase right now, right? So we go through, we yield every edit. Each edit gets extended, right, with its time. So each edit gets extended with its time. Okay. So we, okay. So what we're going to do is we're going to commit something like commit contents, right? Set contents. Get set contents at date. Okay. So get set contents at date. Okay. So this is what we want to do, right? We want to, with the Git repo, set the contents of a file at a given date to be something specific. Git. Right. So, all right. So at given a Git repo, Git repository, set the contents of the given file path to be the given contents within a commit given by the with the date field matching the given date. Okay. All right, we're going to do a lot of rebasing here. We're going to do some automated rebasing. So this is going to be really interesting. Actually, get set file contents at date. This is going to be really interesting for some later stuff where we do automated refactoring. So given a Git repository, you set the given file by. All right, so we're rewriting the past here when we're doing this stuff, right? So repo, Git repository checked out. All right, so from typing import new type. Okay. Ooh, so new type, so object, so spec. So we're gonna check, we're gonna play with this too. Read diffml or read feature get diffml feature get feature definitions. All right, so get repo checked out spec. I think we can we just take a get repo? Should we take a get repo checked out, or should we take a get repo? An interesting question. Well, uh, I think that if we took a Git repository checked or Git repo checked out spec, then as the data type, I believe that the commit would serve us well there. So, because we'd know what would we care about that? I think we might return a Git repository checked out spec. Yes, we return a Git repository checked out spec. Um, this is our return type because we know what commit we're on when we're done with this. Um, set file content set J. Okay, so okay, okay, and then Git repo spec. All right, and okay. Git repository checked out. Lock equals true. So how are we going to do that? It'll be a lineage. So we'll have to have something which says, yeah, like a union with a type that's not real. Yeah, a union with a type that's not real. Or yeah, just doing a union on a definition, I think we can mean maybe we could do a union. Yeah, why don't we do a union? Maybe it's not a union. Yeah, so it's a subclass of a union. So if we had a subclass of a union, we could do lock. So we could say, because the critical piece here is that we want the managed locking for this type of thing, because that Git repo is not going to want to have multiple Git commands run on it in parallel. So typing union. So unions can now be written. How do we subclass from a type? Union is type typed. Is instance types union type. Type inster. Git origin list. I see. Oh, I see. Okay, so because this is for that new operator, so basically if you do list or stir, it should give you union type. The output of this statement where you do two types together with an or should be union type. Okay, so that is to support, where was it? Union. So that is the test, which that that is the test for this case that we're looking at. So types union. Union type. Find out union, union. Union type. Union. Where is union generic alias? Where is this used? Union generic alias. Name optional. Union. Okay. Optional. Okay, so what are we going to do? We're going to say lineage or something. Okay. So we can just return a union of whatever we want. This is, why can't we do this? Okay. Special form. Okay. Uh, special type imperatives. Double union. With lock. With lock. Lock. Okay. Concatenate lock. Callable. Callable. Used with callable to annotate a higher order callable which adds, removes, or transforms parameters on another callable. Concatenate. I think we can put or locked or something. Or maybe we can say, ooh, why don't we say locked? Locked. Okay. Or let's see. Read, write, lock. Okay. Yes. I love it. Okay. So we'll take a lock on this when we want to use it, right? So if I want to use this type, I'm going to take a lock on it. And this means that, the orchestrator will deal with the locking for us. Get repository, get repo spec. All right, yeah, we're experimenting with how we would write these using our new syntax, right? So read write lock. Okay, type alias. So read write lock is just okay. This is derivative of so read write lock is itself a type. Um, New type based on union. Can we do that? Okay. New type equivalent type to be a subtype of an so alias is equivalent derived. Okay, great. So read write lock. So locking. Okay, locking type hence. So locking type hence is actually a union. So if we say read write lock, get repo spec, get read write lock, union with. Okay. So the thing is, read write lock. Okay. So union. We want the type checker to see this thing and go, oh, it's just a get repo spec, you know, um, and say so that we can so that we can annotate appropriately, right? Um, I've been fighting this battle for a while. So here, if we say we want a Git repository, so a locked Git repository needs to be a different type as far as the auto definition goes. Sometimes I want it locked, sometimes I want it don't, right? So this would be a read-write lock. So I need read-write lock on this Git repository if I'm going to use this thing. And I'm going to return to you a Git repository checked out, which you should treat as if it should be. Basically, I'm going to take the lock on the Git repository, and when I return something to you, you're going to need to lock this thing before you use it, by the way. So I'm telling you basically that I'm converting this thing that's a Git repository. I'm taking a lock on it and I'm producing this other thing which is derived from, which also requires the lock, right? So now the orchestration knows, and we'll probably, we can probably leverage NFTs for this. Really nice way to do distributed locking there. I've been looking into a solution to that problem for a long time. So basically, yeah, we take the read write lock on the Git repo when it comes in. We take the read write lock on the Git repo when it comes in, aka the caller should lock that object before calling this function, right? And so why do we do it this way? Because functions should not deal with locks, right? No, don't do that. Is the point. That's a little bit strong, but if you always sort of if you always leave locking to the caller, then each little operation that you write is lockless. And if you need to rearrange things, right? And the main reason, well, why do we care about this locality, right? If we need to rearrange things and redeploy things in different configuration or across different hardware, software, trust boundaries, right, or locality boundaries, if you didn't try to manage the locking internally, if you tried to manage the locking internally, that would be impossible for us. Well, okay, it wouldn't be impossible. We could do it, but it would just be really annoying. And this is going to be much less annoying. So we're just going to sort of declare, and then if you wanted to do a different execution environment or just hard code it yourself, you would just know that you take, this is you add, this is just help for you to know what to do with your locks, right? But if you want to use an orchestration environment that deals with locking for you, then it will use the type hints to do so, right? Because it's going to generate these into the definitions, which are this language agnostic mechanism for doing this, or for communicating the fact that locks need to be taken in some way, right? So this says in our Web3 world, this says, so in Web3 input world, Web3 in when we serialize to/from Web3, we'd see the repo object and the output of this function be treated as NFTs because because we leverage NFTs for distributed locking, right? There can only be one of them. right? Or well, in this case, we're saying there can only be one. Maybe we can say there can only be n, right? We can even have, can even get distributed semaphore functionality by leveraging uh, NFTs, right? So they're distributed semaphores as well if you have like a finite number of them. Uh, if you have a finite uh, non-binary, non-0/1 number of them. I wonder if we can do something where if we have I wonder if there's any sort of thing to be had there about the locked resources, because locked resources maybe somehow translate into uh, uh, locked resources may translate into sort of your failure conditions. And I wonder if there's a way that we could do some sort of analysis um, on all of the things that require you taking a lock in the data flow and your general ability to transform, right? So we're doing this cross-domain conceptual mapping, right, where we predict the different states in that little, A over B equals X over Y equation, right? So we're doing that mapping. So if we have two bottom unknowns, right, we have to use a model here that can predict to this, and or a model here that can predict to this, or a model here that can predict to this and then predict to this, or a model here that predicts from this to this, or a model here that predicts from this to this, right? We just use our model. We have two, right? Two is enough when we have models, right? Actually, one is enough. As long as we have models that we could have theorized about or hypothesize, right? So we hypothesize some, oh, yeah, not theorize. We hypothesize, right? The hypothesis. So there's remembrance, right? Recalling stored data, sort of safe mode hypothesis, potentially not safe, some inference happening there. And then execution, right? Which is we're going and trying doing the scientific process. Um, so I think, and I'm trying to figure out what if we can use this the quantum simulation in any way. And I think that there's something to be had here with, the 0 or 1 as being could I took the lock or not take the lock, and the skew being the likelihood thereof or something, and then encoding the matrix of all of the locks that you might need to take into that, and then somehow telling you, hey, do you think you can make this state transition happen? Do you think you can reach equilibrium of the new state given the old state? Based on these underlying resources that require locking, right? So the real things that are you know um, the sort of looking at a lock as like I don't know, maybe it's not looking at a lock. I don't know, something. I think there's something we can try to predict whether we can do some sort of fast path prediction on the inference of being able to. So there's like, okay, first of all, there's okay, ask Alice to do something, right? Okay, so she starts thinking about it. But and she may start working towards it, right? But this is maybe something where we can say immediately some sort of optimization around that muscle memory, best guessness of her. I don't know, playing with it. I encourage everybody else to as well. Okay, so okay, we also signal to the caller that if they use the returned object, it should we recommend that they lock it. If they don't want to, that's up to them. But we recommend you lock it. because there's some properties of it that may or may not, but we recommend you lock it as the producing operation. We understand that what we are returning inherently has state or has state. Um, uh, this state we also know to be not conducive, not, we also know to not natively support locking slash, okay, and we'll put a little comment here. So similar to TPM resource manager, right? So which locks and virtualizes underlying TPM. So yeah. So basically, you know, if you're not if we suspect that this thing does not provide adequate locking interfaces within the interaction to it, so maybe we're going to return a URL to an HTTP API. Well, let's hope that they're locking. Let's hope that they're locking things appropriately, right? And that we're not just going to, you know, create this giant mess of parallel access, right? But we are always assume that something may be called in parallel and be helpful to those who are calling it and let them know if they're going to need to manage the locking or if the object will manage or anything that they would do with it would be managed already, right? So within that context, right? And so, yeah, okay, I think we got that. Okay. Okay, so get files, content type date. Okay, so we take, okay. Okay, locked. Okay, so then, yeah, because so if we say read write lock on Git repository here, um, it'll just show up as a union, right? But for our analysis purposes, like our static analysis that we're going to do on this type and our introspection, it'll show up as read write lock. But your type checker will just say, meh, it's a union, it's a Git repository, yes. Okay, I mean, hopefully. If it doesn't, I'm going to be pissed. So, okay. Um, what else does this thing take? It takes the date as a string, actually as a date object because we're doing our types. Date to commit file. Date. Oh, look at that. Oh, look at that. That's fantastic. Okay. Oh, wow. Oh, wow. Wow. That's perfect. Okay, this is perfect. This is perfect. This is perfect. Okay, this is perfect. So excited. Okay. Provided the static type checkers pick this type of stuff up. So new type. They should. Okay, date. Date to commit file. Git repo file add. All right, so we're thinking with the data. Actually, we figured out, I realized we need this later. So it would be nice. We should grab a little inspect helper to just say, you know, uh, function dot, like something like data type, and then it would go and grab the data type for the argument. So Like if we said this would be nice, basically. Get argument data type. All right, so callable name, return inspect dot signature dot func dot parameters dot name param annotation. I think it's something like that. I'll be right back. I'm gonna stop now. I think it's something like I can't see that. Class stir. I think this is what it is. And then we could go through here and we could say, like, input definition equals get argument data type. Let's see. Yeah, so like that,